Engineering Dynamics, Session 6, a kinematics of a particle, investigation of projectile motion. So in a motion of a projectile, we do have a horizontal motion and a vertical motion for a projectile. So when you shoot a ball, something like this, we do have a x direction and y direction of projectile. We don't have any acceleration in x direction of projectile, so that's a constant velocity. But in the other direction, in y direction, we do have a acceleration of a negative g. We'll study it more. So in x direction, v is equal to v naught plus time uh, a times t. When acceleration goes zero, vx is equal to v naught, and x is equal the same. So this goes zero, and x is equal to x naught plus v naught times t, and again this part goes zero, so that vx is equal to v naught. So with the same velocity, it travels along the x direction, x component of. But in the vertical motion, we do have a negative g downward acceleration. So in a positive y direction, v is equal to v naught plus ac times t. That's a vy is equal to v naught y minus gt. Y is equal to y naught plus v naught plus a half of a times t squared. So that's a negative half of gt squared, and then replace this one again with a negative g. So that gives you a negative 2 times g times in parentheses y minus y naught. That's the equation of velocity, displacement, and also one based off of acceleration. So in horizontal motion, the velocity in the horizontal or x direction is constant because a is equal to 0, so velocity is constant, and that's equal to v naught initial velocity. X is equal to x naught plus v naught in x direction times time. And in a vertical motion, we just need to solve two of these equations. So one is vy y, or again v squared y based off acceleration. Motion of a projectile is just provided like when you shoot a ball and hit a target on the other side. So there is a theta associated by that, and v naught. There is the x travel, and there is a y delta, or let's say y maximum. That's a y max, where velocity vy reaches to 0 at the climax. Velocity in y direction goes 0, then a downward dive starts. And also we do have a initial coordinate for our ball or rocket, which is from an arbitrary coordinate. At the beginning, we call that x naught, y naught, and this is our origin. So velocity and position, vx and x in x direction. So r naught is equal to x naught I plus y naught j in 2D space. So the first part ax goes 0, so variation of velocity in x direction over time is 0. Variation of Vx is equal to 0, and we do know the x component of velocity is v naught x cosine of theta, based on the configuration of the ball. So that's if this is theta, this is v naught, this is v naught cosine of theta in x direction, and the other one is v naught sine of theta for y direction. So that's vx, and this is vy. So Vx is equal to dx over dt. Also, Velocity in x direction is variation of displacement over time, and we do know Vx is V naught cosine of theta from here. So dx, if you just take this dx from denominator to here, dx is equal to V naught cosine of theta times dt. If you then integrate it, it just gives you integration from x naught to x dx is equal to V naught cosine of theta out of integration, then integrate it from 0 to t dt. Mm. And it just gives you, the first part gives you the velocity in x direction, and if you integrate it and replace it, it just gives you the displacement in x direction. And also velocity and position in y direction. We do know ay is equal to minus g, and that's a constant acceleration. So variation of velocity over time in y direction is negative g, and a integration of dv in y direction from v naught sine of theta, which is the y component of velocity, until vy is a negative g integrating of 0 to t dt. It just gives you the equation of velocity, and that's a negative gt. If this is just a end result of this integration, minus negative gt plus v naught sine of theta. And if vy is dy variation of displacement in y direction over time, and just take this dt over there and integrate it. If you just take this, that's a negative gt plus y naught sine of theta in parentheses times dt. And if you then integrate it, it just gives you, let's see, like this. So if you do the math, it just gives you the y component, y is equal to y naught plus v naught sine of theta in parentheses times t, a negative half of g times t squared. And then let's see how we can calculate time to the peak. What is the time to the peak? And if you do the math, it just gives you time is v naught sine of theta over g. And how we can get that? The maximum height is where the velocity in y reaches to 0, and then dive down is starting. So if we just set the v naught equal to 0, that's equal to 0, it just gives us, and vy is a negative gt plus v naught sine of theta, and if that's equal to 0, it just says a negative gt plus v naught sine of theta is equal to 0. So it just gives you t is equal to v naught sine of theta over g. That's time to the peak. Mhm. Let's talk about pass equation, the travel equation. X is equal to x naught plus v naught cosine of theta times t, and v is equal to v naught plus x minus x naught in parentheses times tangent of theta minus a half of g times this part to the power of 2. And if you remember, if you just replace t by x minus x naught over v, so if you remember, x is equal to vt. So t is x over v naught. So if you divide this part by, if you define this component, that's a t squared. You can simplify the equation, and that's x naught minus x over then over, if I'm not wrong, v sine of theta, v cosine of theta. It just gives you, we need to construct this part for this part of equation. And if you just replace t with this value and replace it in this equation, it just gives you the same constant of the same amount of x minus x naught times tangent of theta, and that's a simplified version of that equation is v is equal to v naught plus v naught sine of theta times t minus a half of g times t squared. That's pass to the peak, or the equation of pass. In next video, we'll solve a projectile example. Thank you.